The Federal Aviation Administration's Aviation Safety Program presents the Safer Skies Aviation Training Series. The Safer Skies agenda originated in 1998 when the administrator and her team identified the most critical and most common causes for aviation accidents: aeronautical decision-making, weather, loss of control, controlled flight into terrain, survivability, and runway incursions. Together, these six make up the majority of all general aviation accidents. We encourage all airmen to view all six presentations. The FAA's primary goal is reducing fatal accidents, and that's a responsibility we all share. Let's take the time to focus our attention on these six critical subjects. Hello, my name is Ralph Hood and I'm the world's most charming pilot. Now actually that's not true. In fact, half my lies aren't true. I'm an aviation humorist from Alabama, and actually we're right here in Birmingham at the Southern Museum of Flight. It's a beautiful aviation museum, but we're here to talk about the FAA safety initiative called Safer Skies. And today we're going to talk about the issue of controlled flight into terrain, or CFIT for short. Acts of war or terror notwithstanding, I think I'm pretty safe in saying that no pilot ever started out with the goal of flying the airplane into the ground. However, that is being done yearly at an alarming rate. CFIT is the event that occurs when an airworthy aircraft under the control of a qualified pilot is flown into terrain or water or obstacles with inadequate awareness on the part of the pilot of the impending disaster.
Terrain, terrain, pull up, pull up.
Too low, terrain.
CFIT accidents are usually fatal and account for 17% of all general aviation fatalities. This program is about helping you identify the issues and the solutions that will help make us all better aviators. The overall goal of the Safer Skies program is to reduce the number of fatal accidents in general aviation. Now that is a lofty and worthwhile goal when you consider that in a recent 5-year period, there were 9,087 general aviation accidents in an estimated 138 million flight hours. That's one accident for every 15,000 flight hours. 19% of those accidents were fatal, resulting in 2,976 deaths. So how do we reduce that number? The first step in finding a solution to a problem is recognizing that there is a problem. And believe me, we do have a problem when it comes to controlled flight into terrain. In just 2 years that were studied, there were 195 GA CFIT accidents. The common denominator in every instance of CFIT is human factors. That means, folks, that somebody simply goofed up. These mistakes can have to do with things like prioritizing, concentration, and crew or cockpit resource management. They all come back to the root of all aviation safety issues: aeronautical decision making, or ADM. I think you'll quickly agree that basic ADM issues are at play throughout the entire process of planning and executing a flight. ADM is defined as a systematic approach to the mental process used by pilots to consistently determine the best course of action in response to a given set of circumstances. Another way to look at ADM is controlling the errors. Error management within the aeronautical decision-making process relies upon situation awareness, problem or threat recognition, and good judgment in resolving the threat or the error. A simple way to apply the decision-making process is the 3 P's: perceive, process, perform. Take in all of the available information, figure out what to do with that information, and then do it. After the perform step, evaluate the outcome of your action, and that starts the 3P process all over again. Perceive, process, perform. That's a good formula to remember that applies to all situations encountered in the course of a flight, from tie down to tie down. So let's get started on our CFIT presentation with Mr. Tom Evans. Tom is a master flight instructor and has been selected as the Southern Region Aviation Safety Counselor of the Year.
Ralph, you're not the only one that appreciates a great aviation museum. I'm here in the Florida Air Museum at the Sun and Fun Complex at Lakeland Linder Field here in the heart of Florida. And I know you've been here because there are stories about you floating around these halls, but you are one up on me. I have yet to go to the Southern Air Museum, but I'm hoping to change that pretty quickly. But let's move on with the program. You know, we pilots by nature are confident, can-do, and assertive individuals. We have to be. And whether you're an experienced pilot or just learning, effective CFIT training is essential because things can go terribly wrong on even a seemingly routine flight. Sadly, too many CFIT accidents seem to be the result of the same errors over and over again. While the number of CFIT incidents have gone down, it's still 20 times more likely to kill you than a mid-air collision. 25% of the CFIT accidents happen during the labor-intensive takeoff and initial climb. 41.4% of CFIT accidents are attributed to final approach and landing. Keep in mind that takeoff, initial climb, final approach, and landings represent only about 6% of the total flight time of a given flight. Clearly, that 6% can be deadly, and you need to be prepared. Like most other accidents, CFIT results from a chain of events. Essentially, there are 2 types of failure that contribute to the chain and get a pilot into trouble. Those you're not responsible for, the latent failures, and those directly attributed to pilot error, active failures. The first one, latent failures, are the deficiency that you, the pilot, do not directly control. They're flaws in various aspects of the aviation system as a whole. For general aviation pilots, these shortcomings include flaws in your training, certification process, deficiency in safety policies, and standard operating procedures, management stability or instability, cockpit and equipment design, lack of weather reporting facilities, and inadequate airport operation and maintenance control, just to name a few. For GA pilots actually working as pilots, communication between management, operational personnel, and the pilot is critical. A corporate safety culture that sets objectives which are difficult or impossible for you to achieve with the resources at your disposal can trigger a catastrophe. Commercial air carriers benefit from rigorous standard operating procedures dictated for every aspect of their flight. A single piloted aircraft as well as a crew GA cockpit can benefit as well from an effective SOP, but flaws in the standard operating procedures and trainings may remain undetected for a considerable time before combining with active failures and local triggers, such as bad weather conditions, to generate a CFIT accident. Active failures are essentially pilot errors as well as mistakes made by air traffic control. Consequences of these errors are often immediately obvious and have an immediate impact, pun intended. There are several types of pilot errors that lead to CFIT accidents, but one of the most common is made by VFR-only pilots operating in marginal VFR IMC, also known as scud running. Just for the record, the FAA does not endorse or approve of scud running. However, some pilots, including those with instrument ratings, continue to fly VFR in conditions less than is specified in the FAA regulations. The pilots continue to fly the aircraft in the less than desirable conditions or tries to fly beneath lowering ceilings, impacting an object, terrain, or water. It's no surprise that IFR flight requires greater pilot workloads, especially for the single pilot aircraft. Combine the heavy workload with bad weather and you had better know what you're doing up there. IFR operations in IMC often result in fatalities, many from loss of vertical and horizontal situational awareness. For pilots with thousands of hours of IFR experience, it's easy to feel immune to the effects of spatial disorientation. This can rear its ugly head in the form of several in-flight illusions, where a pilot believes he or she is correcting the aircraft's attitude, but which in fact leads to a CFIT accident. Check out our Safer Skies Loss of Control DVD for much more information on spatial disorientation. Low-flying aircraft operating in VFR conditions is a special category of active failures for pilots who fly below minimum safe altitudes, some like crop dusters and helicopters for legitimate reasons. These pilots fly regularly near trees, telephone and power lines, and other obstacles. In these failures, the pilot is aware of the obstacles, but factors such as time of day, minimum light, shadows, darkness, sun glare, cockpit blind spots, or fatigue cause the pilot to lose situational awareness and hit an obstacle or terrain. Several situations pose the greatest risk to even the most experienced pilots. One of these is the non-precision approach, which is a standard instrument approach procedure in which no electronic glide slope is provided. While many CFIT accidents occur on departure as well as on the missed approach, most happen during the non-precision approach, which has nearly a threefold to eightfold risk factor over the precision approach. What might be a simple mistake in the flatland flying can readily turn fatal in the high country, is why the mountainous terrain is an extremely volatile environment. No matter how or what you fly, mountainous operations are more demanding due to the complexity of the approaches and the frequent absence of air traffic control radar. Many airports that lie in high terrain are considered special qualification airports by the airlines and Part 135 charter companies. Their pilots are required to undergo specific training and meet certain experience standards prior to flying in there. Although we Part 91 general aviation pilots have no such restrictions, undergoing some form of specialized training can be vital to safe operations in these areas. Mountain challenges include rising terrain, high density altitude, rapidly changing weather, and looming darkness and shadows, high winds, updrafts, downdrafts, and complete obscurations can complicate even the best pre-planned flight. Generally, ATC radar blankets the country, but there are exceptions. Areas that lack ATC services, such as approach radar, pose a CFIT risk for pilots. Not only can ATC confirm where you are and should be, but they can provide help in an emergency, and they have access to current weather information. In mountainous terrains, particularly in valleys, ATC radar coverage is almost non-existent. Just because it's a published approach does not make it perfect. Airports with poorly designed approach procedures contribute to an environment where controlled flight into terrain is possible. And even a perfectly designed approach is a hazard if not perfectly flown. Each published altitude on an approach has a specific purpose. Key fixes in airport elevation must be noted and associated with terrain and obstacles along the approach path. Good aeronautical decision-making means you, the pilot, must study the charts before leaving cruise altitude, and proper execution of the approach or the mist is critical. If, for example, the course between the initial approach fixed and missed approach point and the airport is not a straight line, executing a mist with a turn before the missed approach point could be hazardous to your health. Take an environment fraught with CFIT risk. Add pilot error and watch out. Let's look at the major risk factors and the traps they present. There are 5 common risk factors: omission of an action and/or inappropriate action, lack of positional awareness in the air, flight handling, get-there-itis, and poor professional judgment and/or airmanship. In the situation where there's an omission of action or an inappropriate action, perhaps you can't see anything, but the aircraft is continuing to descend below the decision altitude or the minimum descent altitude. The pilot in command is either controlling the descent or not noticing the lower altitudes, which also could be a result of rising terrain. Rising terrain? It's a new concept to us flatlanders. Minimum safe altitudes, MSA figures, published on the VFR charts and approach plates can be extremely helpful in these situations. Surrounding terrains and/or obstacle heights are also listed. You'll find off-route obstruction clearance altitudes, minimum obstacle clearance altitudes, and maximum elevation figures, MEF. Of all these, MEF is the least conservative, offering as little as 101 feet of obstacle clearance. There's a very good in-depth explanation of these summaries in the form of the safety brief from AOPA's Air Safety Foundation titled Terrain Avoidance Plan. There's linked information at the end of the presentation. It's easier than we would like to believe to lose control up there. But when we aren't paying attention to airspeed, altitude, horizontal position relative to the approach course or rate of descent, we're in grave danger of losing situational awareness. That's why flight handling is a common risk factor in CFIT accidents. Poor flight handling leads to unstabilized approaches, loss of control, conflict with adjacent terrain, and landing overruns, as well as career changes for the survivors. Since pilots may feel compelled to complete planned flights, the get-there-itis and poor professional judgment are common risk factors contributing to CFIT accidents. This pattern can create a state of mind where we measure the success of our flight by whether or not we land at our intended destination at our intended time. The truth is, during every flight, you should be ready to make alternative plans and then carry them out. The topic is covered quite effectively in the Safer Skies Aeronautical Decision-Making presentation. One reason pilots make bad decisions is fatigue. Fatigue can slow your problem-solving ability, degrade your motor skills, and impair attentiveness. Severe fatigue may result in temporary perceptual illusions, such as seeing lights that are not present. Would you guess that a crewed cockpit is safer than a single pilot cockpit when it comes to avoiding CFIT accidents? The crewed aircraft tends to be better equipped with more safety equipment than a typical single pilot small GA aircraft. In the crewed cockpit, the second pilot can make the difference between a safe flight and a CFIT accident. Safety improves when the crew has been trained to work well together and follows the effective standard operating procedures and crew resource management guidelines. With or without all the whistles and the bells in the single pilot airplane, the pilot must be better prepared to avoid a CFIT accident because the single pilots are pilots, navigators, radio operators, system managers, record keepers, and often flight attendants. The obvious problem for the single pilot is the high workload, especially when flying IFR. Of course, the workload and stress go up dramatically when the unexpected happens, putting you in a reactive mode. For every pilot, good planning plus experience and training can save you from a CFIT accident. In fact, from any type of accident. Don't wait until you're 10 miles out to check ATIS. Flight Service or Flight Watch can give you the expected weather at your destination long before you're in range of the ATIS.
Through Mike Charlie, if you've got a moment, I'd like to check some weather along my route.
Here are some of the major errors pilots make that contribute to general aviation CFIT accidents. Inadequate pre-flight, preparation and/or planning, failure to obtain and/or maintain flying speed, failure to maintain directional control, improper leveling off, failure to see and avoid obstacles or obstructions, improper in-flight decisions or planning, misjudging distances and speeds, selection of unsuitable terrain, and improper operation of flight controls. The errors together, or in part, can lead to poor situational awareness, which tops the list of CFIT causes. When you have situational awareness, you're aware of what's happening around the aircraft at all times, both vertically and horizontally. The aware pilot can also project the near-term status and the aircraft position in relationship to other aircraft, terrain, and potential hazards. Situational awareness is most critical at low altitudes when maneuvering for an approach or while on an instrument approach. Flying at night and flying in IMC multiplies the risk of losing situational awareness. So a little extra planning and caution are called for in these situations. Thorough pre-flight preparation is essential for understanding the level of risk ahead. If you execute the flight in your head before takeoff, you'll be better prepared for changes that occur along the route. Charts and disciplined piloting techniques will help you perceive and thus avoid the pitfalls leading to poor situational awareness and flight management. Terrain and obstructions should be studied using a chart that shows elevation contours, preferably a chart with color. This includes thoroughly reviewing the terrain obstruction features, instrument approaches and their respective missed approach procedures, and VFR escape routes around hostile terrain in the event your aircraft's performance is compromised. If you plan to operate in unfamiliar mountainous areas, take steps to arm yourself with area-specific knowledge. Another strategy to help you cope with and prepare for challenging situations in mountainous terrain is to obtain tailored charting services from aviation chart specialists. Jepson and Aeroplanner are two well-known suppliers. Once again, ordering information is at the conclusion of this presentation. I'm sure many of us would just love to have the latest and the greatest equipment to help guide us through our flight. And while high-tech solutions aren't a substitute for good pilot philosophy and flight deck management, electronic aids intended to improve situational awareness and warn of hostile rising terrains are getting better and more affordable. Some of this technology is now cost-effective for general aviation applications. Of course, the more electronic aids in the aircraft, the greater the demands imposed upon you, the pilot. The important thing is to understand and thoroughly train in using the electronics. GPS provides highly accurate position and velocity information and precise time, and gives us a moving map to boot. Used correctly, the GPS can provide increased situational awareness, navigation capabilities, and accurate instrument approaches in locations where no ground-based approach aids are available. If the GPS system is further enhanced to function with a wide area augmentation system technology, Precision approaches to within mere feet are available. The Flight Management System, FMS, uses a large database to help you pre-program your route. The system constantly updates position accuracy. The FMS and its associated database ensures that the most appropriate aids are automatically selected during the information update cycle. This system is normally found in turbine aircraft. And yes, the glass cockpit, EFIS, became standard equipment on commercial airliners in the late 1980s. Business aircraft adopted the EFIS in the late 90s, and it's now available in many new general aviation aircraft. It's designed to show you all the important information on the current phase of a flight in a compact display. The EFIS has two displays, the primary flight display, PFD, and the multifunction display, MFD. The PFD integrates the airspeed, altitude, heading, attitude, vertical speed, and yaw information into one display. Plus, it will alert you to unusual or hazardous conditions. The MFDs displays navigational and weather information from multiple systems. The terrain awareness and warning system, the TALS, is about the most important electronic safety equipment to become available in 3 decades. It's a combination of ground proximity warning system and forward-looking terrain avoidance. When the airlines first equipped their fleet with the first TALS system boxes in the late 1990s, CFIT accidents dropped to 5 or fewer events per year. TALS identifies obstacles and provides the time and information you need to avoid the hazards. Up until March 2002, the technology wasn't required for general aviation. But since then, the FAA has mandated TALS equipment in newly manufactured general aviation turbine aircraft. For older aircraft, the FAA has mandated that all turbine airplanes, including helicopters with 6 or more passenger seats, have to be TALS B equipped after March 29, 2005. Exceptions to this are local area parachuting operations and firefighting water bombers and crop dusters. But the price is reasonable enough that it should be a consideration for any general aviation airplane that flies in IMC or rough terrain. There are 3 classes of TALS boxes, and they all function about the same. But there's some differences in their configuration. They all work off the concept of the database and the GPS. But the Class A has some specific requirements, like radar altimeter and a few others. Class A is required for turbine aircraft with 10 or more passengers. Class B TALS is required for all turbine aircraft with 6 to 9 passengers. Class B boxes can be optioned up to include all the functionalities of a Class A, but the difference will still be that the Class A has 2 components as separate units: the ground proximity warning system, GPWS, and the forward-looking terrain avoidance system, FLTA. Class C TALS boxes are voluntary for other aircraft and function like Class B technology, but with some additionally reduced functions. Class C equipment does not meet the standards of the TALS mandate TSO C151B. Those of you who haven't flown with a TALS yet will see that most TALS terrain maps show the highest terrain altitude in red, with yellow used to show the less threatening terrain and green showing the location of the lower terrain. When a CFIT threat is detected, it's easily identifiable on the TALS display. The 60-second caution alert is accompanied by a 7-point hollow star highlighting the terrain threat you need to avoid. At 30 seconds from impact, the yellow star turns red, and the approach visual and audio warning alerts are triggered, and none of us want to hear that. Before TALS, GPWS was the last safety net we had, because GPWS only considered the space or lack of it between the aircraft and the terrain below. It's a completely reactive system, and when you hear the warning voice, Time is very short to take action and avoid the terrain. KASE is in fact an enhanced ground proximity warning system, GPWS, and it puts time in your favor. Instead of a 30-second warning, pilots hear the alert 1 minute ahead of the obstacle or terrain.
Caution, terrain.
However, remember, the threat avoidance command is still reactive and in one direction, up. But at least you have a little more time to assess the best corrective action. Because the look ahead function is three-dimensional, the pilot has the option of climbing above the terrain or turning away from it to silence the alarm. In the peaks mode, the display shows terrain elevation contours and sea level bodies of water that are well below the aircraft's altitude. This enhances situational awareness in cruise and will help you plan for the descent, the approach, and landing. The installed units range in price from under $10,000 to over $75,000. There's even a handheld on the market for just over $1,000. Determine the best electronics for the flights that you plan on making. Become an expert in their operation and keep in mind they're an aid. The latest electronics can't guarantee a safe flight, but combine them with an important safety initiative underway in Alaska, and you'll see how Alaskan pilots are improving situational awareness and flight management with the Capstone program. In the mid-1990s, the National Transportation Safety Board determined that Alaska had the worst safety record in the nation. This translated into an accident rate 5 times greater than the national average. Flying in the 49th state is risky because there are large areas without communications or ground-based navigation aids. When the weather turns, and it often does, it's a dangerous business. Capstone's GPS and data link powered cockpit displays show exact position, terrains, and nearby aircraft and weather. Most aircraft are within the range of at least 3 satellites at all times. So the aircraft equipped with the satellite communication components are always in contact with the ground and have contact with air traffic across the state, no matter how isolated the region. Capstone aircraft tracking and communications allows ATC controllers to notify pilots of dangerous high winds, turbulence, ice, snow, and other weather issues at the pilot's exact position. Since Capstone was introduced in Alaska in 2002, there have been 40% fewer accidents. It's a great example of how the right electronics for the situation can save lives. Whether you're flying the Alaskan skies or the lower 48, crewed cockpit or solo, standard operating procedures, SOPs, will help you stay ahead of the airplane so that you act rather than react to avoid control flight into terrain. An SOP is built into almost every action taken by the crew of a commercial or military aircraft. We're going to build an SOP around our recurring mantra here in the Safer Skies program of perceive, process, and perform. We gather the information, apply the information to our current situation, and execute an action or a non-action, if appropriate, in response to the information we've gathered and applied. Perceive, process, and perform is an ongoing and never-ending exercise in situation and situational awareness. The final step in the 3P process is to evaluate the action taken, which starts the 3P process all over again. There are several sources for a variety of checklists to help you develop effective SOPs that can work for you. The Flight Safety Foundation publishes a CFIT checklist to help you perceive the risk and take actions before every flight. The form is divided into 3 parts: CFIT risk assessment, risk reduction factors, and your CFIT risk. A negative score indicates a significant threat, and you can determine what changes and improvements you can make to reduce that risk. The FAA's Flight Visualization Tool is a shorter form which can also aid you in assessing your CFIT risk before you ever take off. The form asks you to look at every element of every stage of your flight, departure, en route, and arrival, At the departure and the arrival stage, you'll find a place to write down frequencies and NOTAMs, which I'll go over in a minute. You'll also be able to diagram the airports and prevailing winds. One other option in designing your SOP is the Personal Minimum Checklist, published by the FAA. You'll find ordering information in the links and reference sections at the end of this presentation. We're all familiar with the NOTAMs, which of course is an acronym for Notices to Airmen. But there's another way to use that familiar acronym as a mnemonic word association aid. Each letter cues you to take note of a particular aspect of the landing approach. Remember, the time to get organized for an approach is well before the initial approach fix or vectors to final. In the mnemonic version of the NOTAMs, the N stands for nav aids. Selecting the wrong nav source for a specific instrument approach procedure has become a common error which can cause you to become disoriented and lose situational awareness. It is the pilot's responsibility to dial in the correct nav system, and the NOTAMs, mnemonics, can help you do this. The O is for obstructions. While terrain contours and man-made obstructions are noted on instrument approach procedure charts, it's also essential to check the other NOTAMs for temporary obstructions that may not be shown on your charts, such as construction crane and towers. A construction crane may have been erected since the last publication of the chart, for example. If you're fully aware of the obstacles and the terrain hazards, you're much less likely to turn in the wrong direction on an approach or descend below the critical altitudes. Don't put blind faith in the visual glide slope indicators because they provide obstruction-free glide path guidance for only the last 3.5 to 4 nautical miles of an approach, depending on the design. In an uncontrolled environment like grass fields or anywhere you might need to fly low, a lesson taken from the helicopter community is to fly overhead at a safe altitude and check for towers and hazards before descending to a lower altitude. T is for timing. Because of the extensive availability of the GPS, FMS, LORAN, RNAVs, DME, and other letters of the alphabet, the clock plays a much less prominent role in today's cockpit. But it is an important backup device should you lose your distance readout and are required to fly a timed approach. So make sure you know how to do this. This might be a good time to remind everyone that each leg of a GPS approach gives you distances and times to the next fix, not to the missed approach point, unless of course the missed approach point is the next fix. Altitudes. Most altitudes are dictated by the obstruction clearance criteria as specified in the TERPS manual. Before beginning an approach, a pilot should review and brief all the associated altitudes. It starts with looking at minimum safe altitudes and includes a review of each altitude constraint associated with that procedure. Particular attention should be paid to the glide slope or the outer marker intersection. That's a point which varies with specific approach procedures, but which is typically 4 miles and 1,400 feet above the runway touchdown zone elevation. We know that as the TDZE. It's also important to check for step-down fixed crossing restrictions between the final approach fixed and the missed approach point. They're usually not contained in the GPS or the FMS database, so it's up to you to put off the descent to the minimum descent altitude until inside the crossing restriction fix. Missed approach. Every instrument approach should be planned and briefed from the feeder fix all the way through to the missed approach holding fix, as if breaking out into visual conditions is uncertain at best. Speech. You'll be surprised at how rehearsing your approach plan out loud or even in your head during the various steps of your flight can help a solo pilot. Include all the steps you plan to take in the event a go-around and missed approach are required. In the crewed cockpit, both pilots should review and confirm the verbal cues they're going to use to cue the timely changes in the approach plan. The new SOP is to utilize whichever pre-flight forms work for you mentally. Go through the flight and fill out all the important information. Study and brief both the departure and the arrival. Make sure your co-pilot, if there is one, understands what you're planning. Know the approach plates and the procedures. Have the proper chart and approach plate information because they can help you alleviate CFIT risk, especially when flying IFR and IMC conditions. Know the area charts and the topography. Thoroughly review the VFR charts for important obstacle and terrain data, even if you are flying IFR. When you brief the obstacles, consider there may be others not noted on the chart. Ensure you have complete weather data for every leg of the flight because many GA aircraft have limited range or speed to fly out of unexpected weather conditions. Beyond temperature considerations, it is important to evaluate weather conditions in context with the terrain and then be prepared for weather to change. Consider the external elements and how they might affect the success of the flight. Expect the missed approach, especially when conditions fall close to minimums, and make sure you have thoroughly briefed the missed approach procedure. Ask and verify all communications. Some communication errors and misunderstanding are caused by language differences, lack of standardized phraseologies, readback errors, or heavy workloads. A recent review of the Kansas City Center communications revealed there were 790 hearback and readback errors in 1 month. Create a sterile cockpit and avoid distractions during the critical flight phases. Most airlines have a policy that prohibits any conversation not pertaining to the task at hand from the initial approach fix until the aircraft is parked. If you have a co-pilot, separate flight crew duties when an unusual situation occurs. This will ensure that someone is really flying the airplane. A pilot with mental distractions is in a perfect position for a CFIT accident. Distractions can cause delayed recognition of communication events or can cause you to completely miss an important detail. One way to lessen distractions is to organize the cockpit. There just isn't enough room for everything, so you should pre-select every chart and publication you need. Put them in the order you expect to use them and have them open, folded, or tabbed as appropriate. Have pencil and paper handy. When both hands are busy, you don't want to have to be looking for these things. An approach chart holder centered on the yoke is invaluable. Evaluate which products can help you stay organized in the cockpit. Honor the altitudes. Use every available aid to assist you in knowing your position and the recommended altitude at that position. Know your altitude and distance from the landing airport. Understand that you, not the controllers, are responsible for knowing this information. You have to stay on top, literally, of your decision altitude or minimum descent altitude. Every airport with a published approach procedure has a minimum sector altitude printed on that chart. The MSAs are 1,000 feet above all obstacles in that sector within 25 miles of the facility or of the locator outer marker and an ILS procedure. Honor the missed approach points. It is important to keep in mind the guidance of the AIM manuals. The missed approach point on a non-precision approach is not designed with any consideration to where the aircraft must begin the descent to execute a safe landing. Since there is no altitude monitoring on a non-precision approach, the pilot needs to determine the rate of descent and where to begin that descent. The better you know your airplane, the easier this will be. What power settings, configurations, and speed does it take to track a glide slope, for example? The bottom line literally in any instrument approach is do not bust the MDA or the decision altitude. If you're too high at the missed approach point, try again and adjust. If you're too low, you might not get another chance. Configure for the missed approach. A pilot executing a missed approach prior to the missed approach point must continue along the final approach to that missed approach point. At locations where ATC radar service is provided, you should conform to radar vectors provided by ATC in lieu of the published missed approach procedure. You must be vigilant from tie down to tie down. Whether flying VFR or IFR, each flight has critical flight segments, and how you plan for and handle these flight segments determine to a great extent the safety of your flight. The bottom line, the recommendations for GA pilots are: non-instrument rated VFR pilots should not attempt to fly in IMC. Know and fly above minimum published safe altitudes. For VFR pilots, fly minimum of 1,000 feet above the highest terrain. Fly a minimum of 2,000 feet in mountainous areas. If IFR, fly published procedures. Fly the full published procedures at night during minimum weather conditions or operating at an unfamiliar airport. Verify proper altitude, especially at night or over water, through the use of correctly set altimeters. Verify all ATC clearances and question an ATC clearance that assigns a heading or an altitude that, based upon your situational awareness, places the aircraft in a CFIT environment. A veteran air traffic controller recently said, "Trust ATC explicitly and verify everything they say." Maintain situational awareness, both vertically and horizontally. Comply with the appropriate regulations for your specific operation. Don't operate below minimum safe altitudes if you're uncertain of position or ATC clearances. Be extra careful when operating outside the United States or any unfamiliar area. Use current charts and all available information. Use appropriate checklists and know your aircraft and its equipment. We could have shown you a lot of pictures of CFIT accidents to really hit hard on the gravity of the situation. But we're hoping that if you keep in mind that the majority of the CFIT accidents are fatal, you'll take action to improve your training and flight preparation. Be honest with yourself about your own vulnerabilities when it comes to avoiding controlled flight into terrain. Develop a self-discipline with respect to proper pre-flight planning and aeronautical decision-making, and you can greatly increase your level of safety. The priorities in the cockpit when there's any confusion are always aviate, navigate, and communicate. You've got to know where you are, where you're going, but if you forget to fly the airplane in the process, you'll definitely end up in a crash site, not at the landing site. Ladies and gentlemen, please remember that situational awareness is the master key to avoiding controlled flight into terrain.
When I take a stroll through aviation history in a beautiful museum like this, I'm amazed by how far technology has advanced in a mere 100 years or so, and how far aviation safety has advanced as well. But you know, when we take the time to analyze all of the factors involved in safely completing even a simple flight for a short distance, we begin to realize that the responsibilities that we carry as pilots in command are not to be taken for granted. The goal should be 0 mistakes, 0 errors. Realistically, that's not possible, but when the technical skills under your control are in hand and you've minimized the errors, the potential threats are greatly diminished. But at every stage of flight, there are continuing situations that require your recognitions perceived, your decisions processed, and your actions performed. Those 3 P's, perceive, process, and perform, should be constant and automatic whenever you operate in any flight crew capacity, be it in the air or on the ground. Every GA flight, whether successful or not, begins and ends on the ground. So to successfully complete a flight, you've got to remember one cardinal rule of aviation: don't run into anything. Maintaining terrain awareness at all times is just one more step in our continuing quest for safer skies.